Hello everyone, how is it going? I hope you all are doing well. We have learned physical properties of metals. Now we will learn chemical properties of metals. So, first of all, we will learn what happens when metals are burnt in air. For that, we will learn an activity. Activity 3.9 in your textbook. We have to take some of the samples of metals. We can have aluminium, copper, iron, lead, magnesium, zinc, sodium, etc. We have to take some of the samples and with a pair of tongs, we have to try burning over a flame. So we can use a Bunsen burner for burning the samples of metals. What is this pair of tongs? This tongs is a device which is used for picking up substances without touching it. So here with this pair of tongs we will pick up metals and we will burn it over the burner in the presence of oxygen. We have to repeat this for all the samples of metals. Then we have to observe what happens. What are the changes we observe after burning? You will observe that almost all metals combine with oxygen to form metal oxide. So there is a common reaction which you need to remember. It is metal plus oxygen gives metal oxide. It is very much easy. This is common equation which we can apply for all the examples. Remember, when metal is burned in the presence of oxygen, it makes metal oxide. Let us learn it by taking an example. When copper is heated in air, if a small piece of copper is heated in air, it combines with oxygen to form copper oxide. You can see copper oxide is a black in color. So again, it is same as the general equation. Metal, which is copper plus oxygen, gives metal oxide. Here the name of oxide will be copper oxide because copper is combined with oxygen and it forms copper oxide. Let us see another example. If we take aluminium metal. So when aluminium combines with oxygen, it forms aluminium oxide. If a small piece of aluminium is burnt in presence of oxygen, it forms aluminium oxide. Here you can see both the examples with their chemical equations. 2Cu, that is copper, plus O2, oxygen, gives us 2CuO, that is copper oxide. Example of aluminium, 4Al, that is aluminium, plus 3O2, oxygen, gives 2Al2O3, that is aluminium oxide. In chapter 2, we have learned that copper oxide reacts with hydrochloric acid. We have learned that metal oxides are basic in nature, but some metal oxides, for example, aluminium oxide and zinc oxide, show both acidic as well as basic behavior. These two, aluminium oxide and zinc oxide, they will show both the properties. They will show properties of acids, also of bases. Such metal oxides which react with both acids as well as bases to produce salts and water are known as amphoteric oxides. Please remember, metal oxides which react with both acids as well as bases and they form salts and water. This type of oxides are known as amphoteric oxides. What are examples of amphoteric oxides? Aluminium oxide and zinc oxide. Let us see how these amphoteric oxides react with both acids and bases by taking an example of aluminium oxide. Here, two reactions are given. Aluminium oxide plus HCl, which is hydrochloric acid, gives us AlCl3, 2AlCl3, which is aluminium chloride plus 3H2O. So here, when aluminium oxide reacts with acid, it forms aluminium chloride and water. Similarly, the next equation shows reaction of aluminium oxide with base. So here Al2O3, that is aluminium oxide, plus 2NaOH, that is sodium hydroxide, gives 2NaAlO2, that is sodium aluminate, and water. So this way aluminium oxide reacts with both acids and base. Now, most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. What is alkalis? Alkalis are bases which are soluble in water. Remember, wherever you hear this word alkalis, this means they are bases which are soluble in water. Now here, most of the metal oxides are insoluble in water, but there are some which dissolve in water, which means they are soluble in water. Now the bases which are soluble in water, they are said as alkalis. Which are they? Sodium oxide and potassium oxide dissolve in water to produce alkalis as follows. So these two are the metal oxides, which are the sodium oxide and potassium oxide, which are insoluble, which are not insoluble, which means they are soluble. So sodium oxide and potassium oxides, they are soluble in water and they produce alkalis. So that we can see in terms of chemical reactions. Na2O, that is sodium oxide, plus H2O, water, gives us 2NaOH, that is sodium hydroxide. Similarly, potassium oxide plus H2O, water, gives us 2KOH, that is potassium hydroxide. So here you will remember that sodium oxide and potassium oxide dissolve in water. They are soluble in water and they form alkalis. Which alkalis are formed here? NaOH and KOH, sodium hydroxide and potassium hydroxide. What are these alkalis? They are base which are soluble in water. So we can say that all metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. It is not like that all the metals will combine with oxygen at the same rate. Okay, there is different rate at which the metals react with oxygen. Metals such as potassium and sodium react so vigorously that they catch fire if kept in the open. Here, vigorously means suddenly. So, these two metals, potassium and sodium, they are so much reactive so that they vigorously react with oxygen and they can catch fire easily if they are kept it open. So, to protect them and to prevent accidental fires, they are kept immersed in a kerosene oil. Which are the metals? Sodium and potassium. Now, the surfaces of metals such as magnesium, aluminium, zinc, lead, etc., are covered with a thin layer of oxide. Why? Because the protective oxide layer prevents the metal from further oxidation. What is oxidation? Reaction with oxygen. So, these metals are covered with a thin layer of oxides which prevents them from further oxidation. Iron does not burn on heating, but iron filings burn vigorously when sprinkled in the flame of the burner. What are iron filings? Small particles of iron. So, iron filings burn vigorously, suddenly, when sprinkled in the flame of the burner. Copper does not burn, but the hot metal is coated with a black colored layer of copper oxide. Silver and gold do not react with oxygen even at high temperatures. So this is all about the chemical property of metals, that what happens when metals are burned in air. After performing these activities, we have observed that sodium is the most reactive of the samples of metals which we have taken. The reaction of magnesium is less vigorous, implying that it is not as reactive as sodium. So, this is all about what happens when metals are burnt in air.